10 here on the chapter review, chapter 6. We want to test this inequality, see where it's true at. Right. Big thing is just treat that inequality as an equal sign. So take the log of both sides. Just treat it as an equal sign. So those exponents get moved out front, being multiplied by the log. Okay, distribute log of 6 to both of these, so we get k log 6 minus 3 log 6 equals k log 11. Now, depending on which side you move this onto, it doesn't really matter. That's why we need to come back and always test this. So if we move this k over, k log 6 minus k log 6 minus k log 6, we get negative 3 log 6 equals k log 11 minus k log 6, so we can factor out a k. 11 minus log of 6. And then we can just divide both sides by log 11 minus log 6. Then make sure we put these in parentheses when we calculate our number here. And so we get this number right here, negative 8.8681. And so now I just want to test to see if I'm going to go less than this number or greater than this number. So a good number to pick into the exponents is to try 0, right? So 0 would be bigger than this. So if 0 works, we can say it's k is greater than. But if 0 doesn't work, then we can say it is less than. So we're going to test 0. So 6, 0 minus 3 is greater than 11 to the 0. We know anything to 0 is 1. And that would be 6 to the negative 3, which is 1 over 6 cubed, which is a smaller, which is not greater than 1, so that's false. So that would be false. So that makes greater than this number is 0. 0 is greater than this number. So 0 is greater than the negative 8.8681. And that is false, right? Turned out to be false. So that means we need to do less than. So always treat it as an equal sign and then test it. A number. 0 is a pretty good number to test. Okay, on number 11 here, we just want to rewrite it to look something like this. So basically what they're just trying to do is change the base formula. So I'm just going to use change the base formula on this, which I believe is in section 4. So that is the log of the top divided by the log of the base. And then it's being times by 12 equals 15. And then I can just solve it for this. They see that the log base 8 is on top and log base x is on bottom. So we know it's either this one or it is this one, right? So then we can just easily divide by 12, and that just 15 over 12 reduces to 5 over 4. Okay, now on the test you might be asked to actually, if you had numbers in here, to actually solve this, right? If I had a number in for x, I could actually plug that into my calculator and actually solve that and to see if it comes out to 5/4, right? So they might give me a number for x and then to see if that equals 5/4. So which one is correct? There's 5/4 one. Okay. Piano key, we can tell what number of key it is on the frequency where middle C is by determining if we know its frequency, and then we can count how many keys on a standard keyboard it is from left to right if we just count. So we can plug in our frequency in for F, plug that in for F. We had a problem similar to this on the test in the last part of the review. But you were asked to actually plug in the N and solve for F. Or, I mean, it was a different problem, but. So I have two missing things. I have N is missing, oops, and I have F is missing. So basically, if I just give you one, you should be able to solve for the other one, right? So I give you F, so you should be able to type that in. 261.1 over 27.5. Again, I can use my change of base formula just like I did there in order to put this into my calculator. So that would be log of this fraction 2/6 1.1 over 27.5 divided by log of the base, log 2, and then times that by 12. So if I do alpha link on this, sometimes the 12 will be written up top like that, which is fine. And then plus 1, and we get our answer, which is 39 point something. So if we round that to the 40th, and if you count to the 40th key, you will find middle C there. Okay, in this next part, number 13, we're just asked to rewrite these as the logarithms, natural logs, right? So our base is e, so that means when I switch this, it would just be the natural log of 8x equals 7. Okay, e turns into log base e, which is ln, right? And then 7 and the log would not be on the same side, right? So that's why this 8x and 7x would switch. Okay, this one, rewrite this one. That'd be ln of 17 equals, come on. My pen's not going to work anymore. Great. There we go. Maybe now. Equals to, nope, 2x. Okay, so how you switch the e ones, e raised to something equals y would get switched to ln of y equals x, and vice versa. Okay, so there's number 13 for you. All right, number 14, I'm just using my rules of logarithms, right? So several different kind of ways to do this. Logarithms is when I subtract two logs, I'm just dividing what I'm taking the log of. And then when I'm multiplying something by the log, I can rewrite that as an exponent, right? So this becomes ln of 81 to the 8th. And if you want to calculate that, you can, or you can just leave it, minus ln of 27th to the 10th. And then when I'm subtracting two logs, I just divide. So this would be ln of 81 to the 8th divided by 27 to the 10th. And then I could rewrite 27 as 3 cubed. So 27, I'll write over here, 27 equals 3 cubed. And 81, I can rewrite that as, which we've talked about before in the other video, is 3 to the 4th, right? And then when we raise powers to powers, we multiply. So 4 times 8 would be 32. So this is ln of 3 raised to 32 over 3 raised to 30. Now when we divide by the same base, we subtract exponents. This becomes ln of 3 raised to 2, which we know would be ln of 9. Or I can rewrite that as, specifically rewrite this one as ln of 3 times 2. So this would be a correct answer, and so would this. Right, so all those three mean the same exact thing. All right, we're dealing with continuously compounded interest. She wants to withdraw her money after 5 years, but her friend says she should wait until 10 years. Awesome. So we want to figure out how much money will be in Chow's account after 10 years. Chow's account after 10 years instead of 5 years. How much more money, right? So how much more money? There will be blank money more, so more. So I want the difference between 10 years and 5 years, right? So I want to plug into an exponential compounded continuously interest, which is y equals our principal times e raised to our rate times time. So we know our rate is 0.3. We need to change that to a decimal. So that would be point. Geez, not having my pen working really stinks. Is that okay? So we have our principal amount would be 2,800. So y equals 2,800 e raised to 0.003, and then t is our years, right? So T is our years, and we want to know 5 years, and we want to know 10 years. So basically, I'm going to plug in 2800 E 0.003 times 10, right? And then I'm going to plug in 5 years, so 2800 E 0.003, and then times by 5. And I believe, let me check real quick, for 10 years we get 28885 and 27 cents. And then for 5 years we get 28842 and 32 cents. So how much more do we make if we go 10 years? Well, we would subtract those two, and we get $42.95. $42.95. So is it worth it to wait 5 more years for 43 bucks? Maybe not. Maybe you can do something else to make 42 bucks. Okay, so make sure you read through the problem, right? Continuous interest, that's this one. It's just an exponential with base e, right? And then make sure you know what it's asking for exactly when you put in the answers. Okay, here on number 16, again, we want to be careful with this inequality, so we need to make sure we test this to make sure it's true, because sometimes when we solve this, it's hard to determine when we treat this or flip that. Okay, so let's just treat it as an equal sign for now. Okay, and so we want to just switch forms, so that would just be e raised to 6 equals 2x plus 5, and that is being raised to the third power. So then we could just cube root both sides. All right, cube root to get rid of the cube. So the cube root of e to the 6th. So the cube root of e to the 6th equals 2x plus 5. And then whatever that number is, that cube root of e to the 6th, which we could rewrite that as e to the 6 over 3, which would just be 2. And then we can subtract 5 from that. And then we can just divide by 2. So I'm going to type that in my calculator, see what I get. Looks like you get 1.19. 1945. Okay, and now I don't want to know the inequality. So what this says right here is I can't plug that in, because if I plug that in, I would get 0 here, and I can't take the log of 0, so that's why that's there. So basically I want to see, normally it's always whatever the direction of this one is. Whatever the direction of this one is, this one usually is the same. So you could check in between. So I want to know between -5/2, which is 2.5, and a positive 1 point something. I want to test in between. So there I want to test in between. So I would say test 0. So I plug in 0. 2 times 0 is 0. 0 plus 5 is ln of 5 raised to 3. And 5 raised to 3 is 125. So what is ln of 125? So I take out my calculator, ln of 125, and I get 4 point something, and 4 point something is less than 6, so it is a less than symbol. Okay, so that one's a little bit tricky. Solve it, treat it as an equal sign, put that number in there, and then test a number smaller than that or a number bigger than that. Wherever 0 is, you probably just want to test 0. Plug it back into the original, test it, and see if it comes out nicely. Okay, next part, basically I just want to write population, find my original amount, right? Find out what my original amount is, and then maybe find out what my K should be. So Alaska ranks 48th, state when comparing populations. 1980, the population was 410,000 around there, and in 2017 it was 700,000 around there. Which equation models the population of Alaska T years after 1980? So after 1980 would be my base, the beginning, right? 1980, so I can make that T equals 0. And so my initial population would be the 4,010. So that's either these first two, right? And then I want to find my K. This one is negative, this one's positive, and I know that it's growing, right? So it'd be a positive K. So I know it's automatically that one. But if I didn't, I could plug that in, right? So I would plug in how many years after 1980 is 2017. That would be, what, 37? So I can plug in T equals 37. I don't really have very much room here. So let's go ahead and change colors and say if 410, 851. Ooh. All right, so sorry about that. It needs more room. So here's number 17. And I want to find out in year 17, or 37, sorry, 37. We know the population is 700,000. 39, 700,000, 739,818. Okay, so then I'm just solving this equation for K, right? I want to get it by itself, so I divide by the original amount. 410,851. So 739,818 divided by 410,851 is equal to E raised to K times 37. So I want to get this by itself, right? This K by itself, so I need to take the ln of both sides. So ln of this number divided by this number equals K times 37. So then I just have to divide by 37. Make sure you close off this parenthesis, right? And then hit enter, and you get K equals 0.015159, which we know in our answer is right here. Oh, right there is our correct answer. Okay, so that's how you do it. And then number 2 kind of goes along with that. If the population of Alaska continues to grow, predict the population of 2040. So how many years is that after 1980? So that would be, what, 60 years? So T equals 60. So there, it's a little bit easier. All we have to do is use that equation that we just correctly did. So if you get that part incorrect, you'll probably get 17 be incorrect. So I'd recommend writing out what you're going to type into the calculator. You'll get partial credit, because at least you know what to do. You just got the equation wrong. And I won't put in 60, right? So I type that in, plug in 60, and I get approximately 1 million, somewhere around 1,066,599, somewhere around there. Okay. Okay, depending on how far you take your K out and use it. All right, and then this 18A is we want to figure out, we have this equation for P with given up time in years. We want to see how much power is remaining after 1 year. So all we do, this is just a K equation. We just plug in 1 in for our T, and we see how much is remaining in there. So let's go ahead and do that. So P is equal to 53E negative 0.00. Make sure you get the correct amount of zeros. 42 times 1, right? Oops. Now let's see if that 1 is actually correct. So T is in days, right? So if we want to figure out how much is 1 year, that would be, let's go with 365. 365 days. So we're actually going to plug in 365 for our days because we want to know how many days, how much will remain. So careful there. Make sure you read those so we can plug in that 53. We can do E button raised to negative 0.0042 times 365. Hit enter and we get 11.44. So make sure you realize what they're counting T in, and you might have to adjust that. Now, if a satellite requires at least 10 watts to work, okay, how many days in the radioisotope will be to power the satellite? Okay, so if it takes 10 watts, so that'd be our P, our power in watts. So 10 is equal to 53E raised to negative 0.0042 T. Right, so we're just solving this. We divide by 53, divide by 53. Then we take the ln of both sides. So ln of 10 over 53 equals negative 0.0042 T. Divide by negative 0.0042, negative 0.0042. Type that into our calculator. So ln alpha link 10 over 53, enter, and then divide that by negative 0.0042. It should take T in days, right? And it says in days would be 397 approximately. So I'm just rounding up there, or just rounding 397. Okay, and so that is second part of that. So you're going to have similar problems to this, right? Again, just like this 18A and B, you might be given a T and you got to plug it in, or you might be given a P and you got to find T, right? Same thing with these problems in here. We had to find what our initial amount is, and then we have to find what our K is. Same type of problems here. Okay, number 16, just test that inequality, rewrite those exponential form, solve for x, then test a number, see if it's less than or greater than. Okay, number 15, compound interest formula right here, initial amount, we have our rate as a decimal, right? So you got to switch that, and then read the question, make sure artists want to know what's the difference between 10 years and 5 years. Okay, maybe it just wants 10, maybe it just wants 5. This one got to be a little tricky because these are actually the same, right? So when you rewrite it and you reduce, right, is there any other ways that it can mean the same exact thing? So check that when it says select all, that you go back and check. Okay, number 10, again, check that inequality, rewrite those, take the log of both sides, distribute, get the variable by itself first, factor that variable out, divide by what's not it, check that number, make sure you close off every parenthesis, and then test to see which direction that inequality goes. Okay, this one you might just have to rewrite it using change the base formula, and then maybe you're asked to plug in an x and then see what that actually is, right? Okay, frequency 1, so here again they could give you an f, right, and you plug it in and you just get your n. A little bit easier. Harder would be plugging in an n and seeing how to find f, right? But it's the same problem as some of these others that we've done, like this one up here, right? Same way, we have a log problem, so we get the log by itself, and then we take the inverse of that, which would be exponential, right? So if I wanted to find, say, f there, wouldn't this be n, maybe I can write it real quick, n minus 1 divided by 12, then switching forms, wouldn't that be 2 raised to that exponent equals f over 27.5. So then I multiply both sides by 27.5, and there's my f, right? So anytime you're given an equation with 2 variables, I can give you one, you should be able to solve for the other, right? Because we know how to solve logarithms, we know how to solve exponentials, because we can just rewrite them, right? Correct? We can just rewrite them, just like number 13 there. Okay, so that's it for you on the second part. So if you haven't done the first part, watch that video, look over these, over these solutions.